Okay guys, on this one what we're going to do is we're going to solve for several things involving a classic problem dealing with a plane dropping some kind of package. We'll go with an aid package, and then it landing some distance away. So in this particular case, I've got a plane right here, and I've got a time of 10 seconds before it hits the ground, and it's going to go a distance of 100 meters. Okay, so the first thing we're going to try to find is the height. The second thing we're going to try to find is the velocity in the x direction, and the thing that we're going to do last is the final velocity total. So, if I have this information right here, and I want to find the height, okay, what formula should I use? Okay, if you said your distance in the y formula, you would be correct. And so if we'll remember, distance in the y is equal to 1/2 ay t squared plus biy t. Alright, now, what we do at this point is we'll plug in our numbers. If you'll remember, the time it took to hit the ground was 10 seconds. And remember, that's always the first thing. If you don't have it, that's what you solve for, but in this case we have it. So 1/2 times -10 times 10 squared. Okay? Plus, what is the initial velocity in the y here? Well, if the plane is just flying this direction, it should only have a velocity in the x. There shouldn't have to be a velocity in the y. The velocity in the y should be 0. So in this particular case, it should be 0. So just to show you a picture of what it would look like, just in graphic form, here is your plane. It drops a package right here. If the plane is traveling, if the plane is traveling this way, and this is the velocity in the x, then the package keeps that velocity in the x. It keeps moving forward. The package now has the velocity in the x. But it doesn't have any initial velocity in the y. So its initial velocity in the y is 0, just as if we had dropped something. And the package will follow a path like that, just like it would if we dropped something off of the table, like in the marble lab. Okay? So coming back here, the initial velocity in the y is 0, so 0 times t. Okay? So now what we do is we plug in our numbers. That goes to 0, so it's out of the way. And so we're left with dy equals 1/2 times -10 times 100. Okay? And so we end up finding that the dy was -500 meters, which means it fell 500 meters. Okay? So it fell 500 meters. The height would be 500 meters. Alright. So the height was 500 meters. Now we need to find the velocity in the x. Well, we have a distance here that is the distance in the x direction. It's along the horizontal. So we know the distance in the x. We also know the time. So if you were to find your formula for velocity in the x, then what we would see is the velocity in the x is equal to the distance in the x divided by the time. Okay? And we know that the distance in the x is equal to 100 meters, and we know the time was equal to 10 meters, or sorry, not 10 meters. It was equal to 10 seconds. So we should end up getting a velocity in the x of 10 meters per second. Okay? Which is quite a slow plane, so probably not realistic. It probably would be more like thousands of meters if it was real life. Alright, so the velocity in the x, though, for our particular case was 10 meters per second. So if we go back to the start, Vx is equal to 10 meters per second. The last thing we need to do is we need to figure out the final velocity. Well, if we look at this right here, when it hits down here, the final velocity in the x should stay constant, just like it always has. So Vx should equal to 10 meters per second down here at the bottom. But it fell for 10 seconds. So there is going to be, while the initial velocity in the y is 0, the final velocity in the y down here will not be equal to 0 because it's fallen for that far. It's fallen for 10 seconds. So we have to find a formula for the final velocity in the y. So what formula could we use to find the final velocity in the y? Well, if you'll look at your formulas, there's only one option available, and that is A is equal to AY is equal to VFY minus VIY divided by the time. So the acceleration of the y is negative 10 meters per second squared, and that's equal to VFY, we don't know yet, minus VIY, which is 0, divided by 10. And so if we solve this problem, multiply the 10 up here, we end up getting negative 100 meters per second equals final velocity in the y. Okay? So going back to the beginning, the final velocity in the y, 100 meters per second. Okay? 100 meters per second. And it's negative. And the final velocity in the x was 10 meters per second. And if you'll remember from vectors, we have to add these two things together. So, the final velocity in the x, or the final velocity total, will be equal to Vf squared, velocity in the x squared, plus velocity in the y squared. Alright, and then we can just solve it real quick. Vf equals the square root of the velocity in the x plus the velocity in the y, and both of them must be squared. So the final velocity should equal the square root of